Box plots are the next type of graph that we want to introduce. They help us visualize quantitative data, and they do that by visually representing the 5-number summary. What we see when we look at each of these 3 graphs in example 3 is a box in the middle with 2 lines, one extending out in each direction. Another name for this is a box and whisker plot, because we can kind of think of those as whiskers sticking out of the box. But we have those lines. Each of those lines end in a fence. The fence on the far left end represents the minimum data value in our data set. We have that stretch of line until we hit the left end of that box, that rectangle in the middle. The left end of the box is our visual representation of Q1, the first quartile. The middle line in that box represents Q2, which is also the median, so the second quartile or the median of our data set. And Q3 is represented by the right-hand end of that box, that rectangle. And as we follow that whisker, that straight line out, we reach another fence at the far right end, and that's referred to as the maximum, or that's the representation of the maximum value in the data set. We're asked in example 3 to identify the shape of each of these box plots. The first one, we can hopefully tell fairly easily by looking at it, that we have something that's approximately symmetric. If we draw a line of symmetry right through that second quartile, right through the median, we have something that's a mirror image of itself. The whisker, or that line sticking out to the left, is very equivalent in length to the line sticking out to the right, and the box seems to be about the same length, same size on each side of that second quartile. So we would refer to this first distribution as being approximately symmetric. The second one we would refer to as being right skewed, where again, whether we reference right or left deals with the tail. In this case, we have this tail, or the line sticking off to the right. So we would say, since we have that line longer on the right-hand side, we would say we have a longer tail on the right end of that distribution. Since the longer tail is on the right end of that distribution, we refer to it as right skewed. And the last one would be referred to as left skewed, since that longer tail, that longer line sticking out of the box, is on the left-hand side. Again, we have a left skewed distribution. Box plots are good for any type of numbers. They're also good for very large data sets. So for these first 2 characteristics, it's very similar to histograms. Also similar to histograms, they hide a lot of the individual data values, which again isn't necessarily a bad thing, especially if we're dealing with really large data sets. It's too much information for us to process, but it does have the perk that it shows us that 5-number summary. Helps us see the different breaks in the data.